All right, so let's do number 25 out of 8.5, which says do the usual A through J, or I, or whatever it goes through, for f of x is the absolute value of x plus 7 minus 12. Okay, so this one is vastly helped by the fact that we did shifting rules. Do you remember those things?
Yeah.
Okay, so I might remember that this is the absolute value thing, right? So this looks like a v, right?
Yeah.
And then I modified the x's by adding 7, which moves left. And then I subtracted 12, which moves down. So I got left 7, down 12, and then this little dude here, right, makes a V shape. Oops, V shape.
Yeah.
You guys cool with this?
Yep.
So I've got a V shape, left 7, down 12. I'm looking for what's the vertex, right? That's part A.
Determine the vertex.
So the vertex was at, when I just had a V, where was the vertex? 0, 0. Then I moved it left 7, down 12. Where's the vertex now?
-7, -12.
-7, -12. Awesome. Another thing you could do is you could plug in values and graph this thing, right? That's what the book really wanted you to do, but we did this chapter 12 stuff, so I figured, what the heck, let's use it. If you want to graph this thing, you make your table of x and f of x values, right? And then go until you find that v. I would recommend some kind of an approach like this. On this one, you're going to be here a while. You guys see that? Or you could think about this thing. When does this thing switch from positive to negative?
Yeah.
When's x plus 7 equal to 0? How about that? When x is -7. That clues you that your -7 one down here is going to be kind of special. That's going to be where it flips. That's going to give you the bottom of that v if you spend a second fiddling with it. That takes way more time than being like, oh, it's left 7, down 12. Cool? Somehow figure out where the vertex is. He's going to ask you, is this thing open up or down?
Up.
Yeah? Cool with that? Up? Why does it open up, guys?
Because there's no negative in front of the function.
Yeah, because we never flipped it over, right? We just moved it left 7 and down 12, so it's still pointing up. Okay. C is probably x-intercept?
Yeah, x-intercept.
Okay, so what are the x-intercepts? Where do I get those? Ooh.
When y.
Yeah, when things are on the x-axis, right?
Yeah.
That means that output's 0, right?
Yep.
So that's me needing to set 0 equal to, yeah, f of x, right? So I'm looking to set 0 equal to my function rule. Then what?
12 on the other side.
Okay, we're going to solve for x, so we're going to add 12 to each side. So 12 is the absolute value of x plus 7. Then what?
You're going to just solve for x.
Yeah, you want to think about two things happening here, right? Because if some stuff in an absolute value is 12, right? That means the stuff in there was either positive 12 or negative 12. You guys all see that?
Yeah.
So really the unbarring thing is just adding plus or minus. right? So I'm looking at plus or minus 12 is x plus 7. You guys see that? It's a little bit like doing plus minus square root to both sides, except I don't need this square root here. Because there's no squaring, right? I just made it positive somehow. So now I want to worry about, okay, it was either positive or it was negative. Here I am. What do I do now?
Set it up.
Subtract 7.
Yeah.
So now I've got x is minus 7 plus or minus 12. So x is minus 7 plus 12, or x is minus 7 minus 12.
Yeah.
What do you get?
5 and negative 19.
Okay, so x is 5 or x is negative 19. So those are my x-intercepts, right?
Yep.
5 and negative 19. Oops. Commas are a bad idea because they look like points. How about like that? So far I've got a vertex, up, and 2 x-intercepts. Does that make sense? Another way you could get these is you would find them in this process, except for the negative 19 one. You'd find the 5 one, right? Or you could think, okay, it's a v. I shifted it back 7, down 12, right? I could count over 1, up 1, over 1, up 1, 7 times, right? Because remember those v's go over 1, up 1. Be super annoying, right?
Yeah, definitely.
But I'd get there eventually. It's going to take a while because you did minus 12, right? So you got to go 12 over 1, up 1s. But that's right 12 and left 12. That's exactly what we did to get here, right?
Yeah.
We took our 7 and then we went right 12 and left 12 from it. So however you straighten those out. How about D? D is actually easy.
Y-intercept.
So y-intercept.
Negative
plug 0 in for x.
Okay, plug 0 in for x. So when you plug 0 in for x, you get
7,
7 minus 12 is
negative 5.
negative 5. You guys see that? Y-intercepts are always easier because they're an evaluate question. X-intercepts are always a little harder because they're a solve question. All right. What's our next piece? E.
Domain.
Domain.
Domain and range. Okay. So E is domain.
All the numbers.
Nice. Why is it R?
Because of the absolute value.
Okay. Yeah, because the absolute value takes all the numbers fine, right? It doesn't sweat it. Or I could think to myself, hey man, it's a V shape, right? If you smush it onto the inputs, you're going to get all of them. Just pull that. So that shouldn't be a stretch. F, the range, this might be a bit of a stretch.
Negative 12 too.
So that's me smushing this way, right?
Yeah.
But I know something about that V shape, right? I know where the bottom is.
Right.
Negative 12.
This bottom point is negative 7, negative 12,
Right.
right? So what's the lowest this V shape ever gets?
Negative 12.
Negative 12.
Negative 12, right? The height on that coordinate. So I get from negative 12 up, right? So like this.
Closed and open.
Very nice. Closed and open. Why is the bracket on the negative 12 closed?
Closed and open.
Yeah, it actually gets there, right? Because there's a closed dot there. Also, you know, I know there's an input that goes there, right?
Yeah.
That input is negative 7, right? Because this thing's an input-output pair. Let's see. FG is positive.
Oh, sorry. Determine the x values for which the function is positive.
Positive. Okay, so this thing is positive. For this one, I might need a better picture, right?
Yeah.
I already have all the stuff for a better picture. I know it's a V shape.
Yeah.
I know it opens up. I know the bottom's at -7, -12, right? So, oh yeah, I know the x-intercepts. That's really convenient. Right, so the x-axis goes through here, something like this. This one's at
5.
5, and this one's at
Negative 19.
-19. Okay, so the y-intercept, or the y-axis is someplace here.
Right.
Okay, so now I've got a pretty good picture. So when's it positive?
Above.
Negative infinity to negative 19.
Okay, see that? The outputs are positive when I'm above the x-axis, right? So I'm looking for the x's that correspond to stuff above the x-axis. So one thing you could do is you could think, cover this part of the picture up and smash like a domain. Right? So I get starting here going that way and starting here going this way. That'll read as negative infinity to negative 19, union 5 to infinity,
Yeah.
brackets.
Around 5 and then 19.
Why? Yeah, because those are still positive outputs, right? Because 0 is positive. And then y opens on those. Yeah, because infinity is not a number, right? So we're not going to close it.
Hello.
Okay, so there's g. H is negative.
Yes.
So negative on, what would the laziest way to phrase this be?
Oh. Yeah.
No. The laziest way to phrase it, the laziest correct way to phrase it, on the rest.
Oh, no.
Right? Because if it's not positive, it's negative. So remember, these two things should add up, right? So here I should get negative 19 to 5. And these two between them should cover almost everything, at least. In this case, I double covered 19 and, or negative 19 and 5, right?
Yeah.
Because those were the spots where it was 0. And I counted that as both pieces. Okay, see that? All right. I comes after H, right?
Yeah.
And this one's decreasing.
Increasing. Yes.
Decreasing?
Yes. X values decrease.
So decreasing on. So maybe you need your little mnemonic guy for this. Your little fellow. Keep in mind for this one, the x-axis. The x-axis important or doesn't matter? I forget.
It is important.
Okay. All right, so where's this decreasing? What does decreasing mean?
Negative
Going
infinity to
down.
negative 7.
Going down. So where's the guy walking downhill?
Negative 7.
Okay, so we're all agreed it's from negative infinity, right?
Yeah.
And then we're maybe a little bit stalled as to whether it's negative 19 or negative 7. Remember, he doesn't care whether he's above or below grade, right? He just wants to know when he's walking downhill. So is this guy going to walk downhill through this stuff?
Yes.
Yeah, he'll be on negative numbers, but that's not really important, right? Still downhill. So I'm reading that as negative infinity to negative 7. Open bracket on this side and
Could be open on that side, right?
why 7, not 12? That's a good question. Why did I use 7 and not 12? Yeah, because we read these increasing, decreasing, positive, and negative. They're all inputs.
He's asking for the
Yeah, so the inputs, this first coordinate, right? The outputs, that coordinate. So I'm asking which inputs is the guy walking downhill for?
Yeah.
So we're decreasing on negative infinity to negative 7, and we still haven't decided on a bracket here.
Not exactly.
It's open. Sorry, that's just badly open. It's open at negative 7 because at this little V at the bottom, right? You're not really going up or downhill, right? You're kind of, you got your foot caught in the bottom and now you can't figure it. Yeah, exactly. You're in this kind of weird limbo space between going down and going up, right?
You're taking a break.
Yeah, exactly. You found a flat spot. Well, in this one you found a kind of a funny spot, right? It's not even flat, it's kind of a pointy spot. And J is increasing?
Of the X value.
So we're increasing on negative 7 to infinity. You guys see that? Why?
Talking about the input, not the.
Yeah, we're talking about the inputs for which we're going up. Also, it should read as the other stuff. Right? These two should also add up. Really, the 3, increasing, decreasing, and constant should all add up. But we don't have any flat spots in here, right?
That's right.
Yeah, maybe that little one at the bottom. That one's not really a flat spot. That's like a pointy weird spot. Questions on this? Did I answer your question? Okay, cool.